In this video, I'm going to explain to you what the range and the domain are referred to when we look at graphs, but also how to record the range and domain in set notation. So using this graph as reference, the range and domain tells us where this graph itself exists in the Cartesian plane. Now the range itself talks about the horizontal sort of period that this graph exists in. So this particular graph, if we were to look at it, the range is this area just here, going through -2. Just haven't drawn that all that well. Where the domain tells us how far across the graph extends. So it's this part in here. Now when we want to refer to the range and the domain, we can refer to this in a number of ways. I'm going to show you set notation to begin with, and there might be some new symbols for you to get to know. Now when we're referring to it, we've got to break this up. So we've got to start with the domain. You could start with the range, but we're going to start with the domain and talk about how we state the domain of this graph, how we state it exists from around this -3, I'll talk about these circles as well, to this 4. Now before we do that, we better just review these circles. You got to remember that this open circle over here means that this graph goes to that point but doesn't actually exist on that point, where the closed circle means that the graph goes to that point and exists on that point. So we've got to somehow say that our domain exists when x is going to be greater than 3 but equal to and less than 4. Now do that with set notation. We begin by using this style of bracket just here, and we say that we're going to state the domain, and we use this x sort of bar to do that. Now from here we've got to state where the domain is. Now I just said before, it starts on this negative end when x is greater than -3 but not equal to. Now to state that, I'm going to put this -3 down just because I've got another one over here that I've got to mention, and I know I can do it all at once. And our x has to be greater than this -3, okay? Not equal to, just greater than. But it also has this right limit, okay? It can't be any greater than 4, but it can be equal to 4 and can be less than 4. So our x can also be equal to or less than 4. And then we end with this curly bracket. So that there is our domain stated. Our range is done in a very similar manner, except instead of using x bar, we're going to use y bar to be able to state that we're mentioning the range. Now from here, we're going to start with our lower limit, so the bottom sort of area here. Remember, it doesn't actually exist on that point, but it's going to be anything greater than this point. So it's going to be anything greater than -2. So our y is going to be greater than -2, but it stops on this point here. So it stops at +3. So our y can exist anywhere between here, but nothing greater than it. So it can be equal to or less than +3. And here is our domain and our range of this graph. So now let's have a look at some different examples here to, I guess, introduce to you some different tricks or things that you might need to know when you're stating the range and domain. So let's start with this quadratic that we've got down here. Now we know with all quadratics that the x value can exist infinitely positively and infinitely negatively. So in essence, the domain of this graph is going to be infinite in number of values, and it can be every single value. So what we need to somehow mention is a way to say that our x or our domain can be any real value. So what we do is, like we did before, we do our x bar with our curly brackets. It's a dodgy one. And then we say that our x can be any real number. And that's what this sort of statement says. Our x can be any real number. So moving on to our range, we're looking at the vertical part of our graph. So we know that up here, it just infinitely continues forever. However, its minimum value that the y ever gets to is -3. So we've got to say that it's got to be equal to that -3 or greater than that -3. So to do that, start with the curly brackets again. And our y has to be equal to or greater than that -3. And now we have the domain and the range of this graph. So now let's have a look at what happens when we start dealing with some rational functions. So here we've got this hyperbola graph that we know infinitely gets closer and closer and closer to the asymptote, the vertical and the horizontal asymptote, without ever touching it. So if we were to focus just on the domain, how far across to the left and to the right this continues going, we can see that it can be any value to the right, any value to the left, and it can be any value in between except for 1. It can't be x is -4. It can be really close to x is -4, but it can't be x is -4. So when we mention the domain of this graph, what we say is that our x cannot equal -4. It can be any other value, just not -4. So when we look at the range, we look at this vertically. So once again, we know that it can continue infinitely, both positively and negatively. And it can be any value in between except for y equals 1, where the horizontal asymptote is. So just like the domain, we mentioned that our y cannot be equal to our asymptote of 1. Can be any other value but 1. So now let's have a look at our final graph. What we can see here is we've got a vertical asymptote at x equals -2, a vertical asymptote at x equals 3, and a horizontal asymptote at the x-axis for these two lines, not this one. This one has a minimum point of 1/2 and 2. So let's just focus on our domain, which is really focusing on our x. Over here, our domain can be anything less than -2. It can't be -2. In between these two lines, it can be anything in between -2 and +3. Then, after that, it can be anything greater than +3. So the only two values that it can't be is when x is -2 and when x is +3. So what we say for the domain is that x cannot equal -2 or x cannot equal +3. Now this symbol here means or in mathematics. You can also write out or if you prefer. So instead of using this symbol, we can write out or like this. But we know that our domain can be any value except for when x is -2 and except for when x is +3. So now let's take a look at our range or our y values. Starting over here, we know that we've got a horizontal asymptote at the x-axis. So we know that y can be anything less than 0. Over here it's the same. Y can be anything less than the horizontal axis, so the x-axis, so y can be anything less than 0. However, it can't exist between 0 and this point here, when y is equal to 2. But it can be anything from 2 or greater. So y exists anything less than 0 or equal to or greater than 2. So that's what we're going to say. So our y can exist when it's less than 0 or when y is greater than or equal to +2. So in summary, the range and domain help state where the graph exists in the Cartesian plane and can tell us some important properties about our graph. We can use set notation to identify what the range and domain are for each, and you can see that there are some special cases that you need to be aware of.